We were looking at chapter number 5, the minerals and energy resources. Hazards of mining, because in India we have various mines and people are working there. So they are facing some problems and there are hazards. You can say the hazards comes with this mining, like the pulmonary diseases caused by dust and noxious, obnoxious fumes from mines. This affects the health of the miners and the people who are involved in this industry. Inundation, that is the water coming inside or flooding inside, and the fires in mines and collapsing of the mines roofs sometimes pose a serious threat to miners' lives. And mining contaminates the nearby water sources also, owing to dumping of the waste and slurry. And the land degradation is caused as land is dug quite deep for mining, and this makes it unsuitable for any further use after the mining site is abandoned. So we really require the conservation of minerals. Only 1% of the minerals, only 1% of the earth crust is of minerals. That is, if you take a globe, say it is 100% earth crust, only 1% is the minerals. So the way we are utilizing it, we need to do something for the conservation of minerals. So conservation of mineral is quite necessary. Actually, it's not necessary. It's now indispensable. You have to do it. It is necessary because mineral formation, the speed, the pace of mineral formation takes a lot of time, millions of years. That is, it is an extremely slow process, gradual process. So the rate of consumption that we have should not overshoot, should not overgo, should not overpace the rate of replenishment. Only 1% of the total mineral deposits are accessible. There may be more, but they are not physically or economically accessible or viable. Minerals are limited resources. We can count it. The number are countable, and eventually they will get exhausted if not used judicially and not used in a sustainable manner. Now coming to the conventional sources of energy, because we can classify the energy resources into two parts. That is, conventional energy resources and non-conventional energy resources. So conventional energy resources, we have been using it for long. That is, for example, if I take an example of firewood, then we have cattle dung. Let me write it cattle D. Then we have the coal, the petroleum. Then we have natural gas. And of course, the electricity, both in the hydel form as well as in the other form, which is thermal. These all are being used as conventional sources of energy. But because we just learned that why we need the conservation of the minerals, etc., and the conservation of energy has to be there, because most of the energy which comes from to the developing economy comes from these. So there has to be some other way. So we have non-conventional sources of energy, and this includes, let me write non-conventional energy resources. So this includes the solar energy, that is the sun's energy. Then wind, of course, some areas get really nice wind. Then we have tidal energy. We have a long sea coastline. Then geothermal, this we have. And then we have biogas. And of course, the atomic energy. So these are the non-conventional source of energy. If you see that in the rural area, this upla, that is gobar cattle dung, this is used mostly for cooking, and this one type of time a meal is made by a woman, she takes 100 number of cigarette, the smoke she takes. So we need to discourage this cow dung cake kind of these resources, energy way of producing things is not good. And also, when you are making it, you are consuming or you are depleting the good thing, or called as manure, that can be used for the agriculture. So let us talk about these conventional sources of energy. Let me show you before that. This is a view of inside of a coal mine. So this situation is not very good, and people working here are facing a lot of health hazards. This is a view from outside of a coal mine. How does it look? This is inside. Now coming to coal, this is the most abundant fossil fuel available in India. So how this coal is made? It is made by the plants and trees which might have buried, plants and trees buried long back. They might have died, or they might have lived their life, and then we have soil on this. So here they face the temperature, the pressure, the compression, etc. And finally in million years they convert to coal. So there are certain types of coal we have, like the lignite, bituminous and anthracite. So what are these? These are different types of variety of coal we get. So lignite, this is a low grade brown coal. It is soft, it has high moisture, that is water content, and it is found in various places. We have one example, Neyveli in Tamil Nadu. Then we have bituminous, most popular used coal this is, and this is used in smelting iron in a blast furnaces. Then we have anthracite. This is a high quality coal, very good type of coal. And these are found, as I said, the anthracite are found in Damodar Valley, West Bengal, Jharkhand, Jharia, Raniganj, Bokaro. These are important coal fields. And this coal is also found in the northern eastern state like Meghalaya, Assam, Arunachal Pradesh, etc. I will take you to the places where we'll find them. And then we coming to the another source of energy, which is petroleum. Petroleum, this is found in the rocks of tertiary age. That is, again, it takes a lot of time to be made, and 63% of the petroleum which we know in Indian region comes from 63% comes from Mumbai High. It's an offshore. It's an offshore that is inside the sea. It's a place where the oil is being dug, petroleum. 18% from Gujarat's Ankleshwar oil field, and 16% from Assam's Digboi, Naharkatia, Moram, Hogrijan oil fields. So Digboi in Assam is the oldest oil field of India. So mostly wherever we get this petroleum, we always get the natural gas. Natural gas is the gaseous form, always, generally, I must not say always, but generally found above petroleum. Wherever we have the content petroleum available, then natural gas can be there. So first natural gas is extracted. So environment friendly, owing to low carbon dioxide emissions. Natural gas produces less carbon dioxide emissions, and as we know, CO2 is the gas responsible for the global warming. So whichever fuel is producing less carbon dioxide, it is good for us. So if you compress this natural gas, it becomes CNG, compressed natural gas, and this can be used in vehicles, as we see in various big cities. CNG is being employed, especially in Delhi. And this natural gas is found in Krishna Godavari Basin, Gulf of Cambay, Andaman and Nicobar Islands, and Mumbai High. And they are transported through pipelines from where they are produced. For example, Hazira, Vijaypur, Jagdishpur. This is called as HVJ line. And this is the longest, around 1700 kilometer pipeline that transports gas from Mumbai High to Basin. And there are various other routes it's follow. I'll just show you. But before that, we have electricity. Now, electricity can be made in different way. That is, we are using electricity and we are producing it in a turbine also, by using the water. Water has a mgh, that is potential energy. When it is on the height, when it comes down, it gains kinetic energy, and the turbines can be moved, and then with the electromagnetic induction, the current can be produced, electricity can be produced. So this is the one way which we use it. And the second is we use the coal, etc., coal and other fuel to produce electricity, coal, petroleum, natural gas. So this when we use, and we call it as a thermal power, that is by burning the fuels like the coal, like the petroleum and the natural gas. If we drive turbines, this is through water, but if we use these coal, petroleum and natural gas to drive turbines to produce thermal power now. So this is called thermal power, but the electricity remains the same. So electricity, we have hydroelectricity. This is done by the force of water that I just showed. Bhakra, Nangal, Damodar Valley projects, they generate hydroelectricity. Also we have the Kopili Hydel project, that is Kopili hydro projects, and they produce hydroelectric power. And the thermal electricity, that is we burn these coal, petroleum, natural gas in order to produce electricity. This is by coal, petroleum and natural gas, and there are around 310 thermal power plants in India. But the problem is they use these non-renewable fossil fuels to generate electricity. So these are the places which we need to understand, that where we find the coal, where we find the coal mines. So let me show you this area. These are the area of coal fields. These are the area of coal fields, and this is the Gondwana land. This is the tertiary land, and these coal is around 200 million years ago back. The life of this coal we find here, and the coal we find here is around 55 lakh years back. So these are the coal fields, but we have this triangle shows that we have coal mines like Singrauli, Korba, Singreni, Talcher, Bokaro, Jharia, and also here in these places. Then we have oil fields. So these are the oil fields. We have Basin and Mumbai High. Then we have here also at the Ankleshwar place, and from here, let me show you here also. There are places here where we find the Diboi, etc. These are the oil fields. But let me show you this 1700 kilometer HVJ line. This line goes here. See, it goes here, and it has various sub you can say tributaries also, and it goes up to this point. So this is how the content or can be transferred. So this line is HVJ natural gas pipeline. So this natural gas goes here, and we have major natural gas reserves in this place, here, and here also we have gas. See, this the lower part of northern eastern state. Then also we know that these are the major natural gas reserves. So these are in reserve, so we'll be using it. Then coming to the nuclear and thermal, I will be talking about nuclear just now, but let me show you this triangle. So because you have to remember this name, this is coming just now. This is Kakrapara. Then we have Tarapur, Kaiga, Kalapakkam, and we'll talk about others also. This Narora. These are all the nuclear power plants. Then we have so many thermal power plants where we burn the coal, petroleum and natural gas in order to produce the electricity. And if you know this, Kalpakkam is indigenous. Others are with the help of French, Americans, etc. This nuclear power plants has been made. So that's what I was talking about. This is nuclear energy. So this is obtained from the nuclear fission of radioactive elements like uranium and thorium. So the nuclear, there are two reactions which gives us immense amount of the energy, which is nuclear fission and nuclear fusion. So nuclear fission in the controlled environment can be used to produce electricity, or you can say power. So we use uranium and thorium for that. So uranium and thorium, they are found in Jharkhand, Rajasthan and Kerala. And then India has 6 nuclear power stations. We just saw some of these in the map. Rawat Bhata in Rajasthan, Narora in Uttar Pradesh, Kalpakkam in Tamil Nadu, Tarapur in Maharashtra, Kaiga in Karnataka, Kakrapara in Gujarat. So these are the various important power stations. So there are, as I said, that uranium and thorium, we find it in different places. So these are the places we just saw, Jharkhand, and we have this in Rajasthan. It is found in the Aravalli ranges, and in Kerala also we have monazite sand, monazite, monazite. This monazite sand in Kerala, there also we find rich number, means we find good value of thorium. So now coming to the India, which is we have a very good solar energy because the latitude in which we are located. So India is a tropical country and we have enormous potential for solar power. So solar energy can be converted into electrical energy, that is the solar energy can be easily converted into electricity using the photovoltaic technology, that is photovoltaic, converting photo or the thermal energy into the electricity. So largest solar plant in India is at Madhapur. Please understand, largest solar plant in India is at Madhapur, Gujarat, and maximum potential is, because the region which get heavy thermal energy, or you can say sun's infrared energy, you can say Rajasthan and Gujarat. So we have many possibilities here. Even before that, people are using the solar cooker, etc., solar cells, and the solar lights. They have been using it. So this is an example of a solar operated electronic milk testing equipment. This is just to show how this solar energy can be harnessed and they can be employed. Coming to the wind power, we have again very good wind, that is anything which is 10 kilometer wind flowing 10 kilometer plus, 10 kilometer an hour plus, then wind power can be harnessed, it can be used. So India is a wind superpower. We are wind superpower. Actually, we are 5th in this place if you take all the world. So the largest wind farm cluster, if you see here, this is an example showing this. This is a wind, wherever we have this windmill, like a fan it is, wherever it is installed, it is called cluster, it is called farm. It is called farm. So we have largest wind farm cluster in Tamil Nadu, and this has variation, or you can say belt from Nagarcoil to Madurai. So you see there, this is the range where these are installed. And apart from this, you get it in Andhra Pradesh and Maharashtra, Gujarat, Kerala. They also have a very huge potential for tapping the wind energy. So the Andhra Pradesh, Karnataka, Gujarat, Kerala, Maharashtra, Lakshadweep, they also have wind farms. And this, as I said, Nagarcoil and Jaisalmer, they are also well known for its effective wind energy harnessing. Now coming to the biogas. See, this biogas, this is a biogas plant, as you see. The biogas, is produced from the waste, farm waste, animal waste, human waste. And this is quite effective than firewood, dung cakes and kerosene. And you don't have to do anything. Just put the waste material here and the microorganisms and the various processes will automatically gives you a very clean fuel that is called biogas. So used mainly for domestic consumption in rural areas. So many people you will see gobar gas plants. So gobar gas plants, they are set up in rural areas which decompose organic waste and produce gas as well as provide manure. Once the gas is being produced, the content which is left, that is the slurry can be used in the agriculture field as manure. Then one more important thing is of energy, which is the non-conventional energy source, is tidal energy. Now this tidal energy is because of the tide, low tide, high tide. So these tides are mainly because of the sun's motion. So whenever this can be harnessed, that is energy of the oceanic tides is used for producing electricity. It can be used. So Gulf of Kutch has a great potential for tidal energy. So all the Gulf, actually whatever khadi we have, khadi or Gulf, these are the places where it can be employed. For example, how does this happen? I'll just tell you about Gulf of Kutch. There is a 900 megawatt tidal energy power plant is set up here by the National Hydropower Corporation. Megawatt. See, just because they want to use the tidal energy. So how does this happen? The water is coming in the high tide, so there are gates. And this goes inside, so the gates are closed. So when they come out, there is a pipe, and there is a very pipe, and there is a speed which this water comes back because of the flow. So here the turbines are placed, and these turbines are moved, and this is how tidal energy can be harnessed. Then one more important energy is geothermal energy. So this geothermal energy, it is the energy, if you see the earth crust, this, if you go inside, we cannot go inside, but it is very hot. Even it is so hot in the crust that you see when the volcano erupts, it gives you molten lava. So it's so heated up here. So there are places near the earth crust which are quite heated, or they have the energy, and this is called the geothermal energy. So it is the energy produced by using internal heat of the earth. The hot springs in India, they are very ideal source for the generation of geothermal energy. So Manikaran in the Himachal Pradesh and Puga Valley in Ladakh, they have geothermal power projects. So now the important thing is conservation of energy, because energy saved is energy produced. We must see that all these things which are going on, we are utilizing various energy resources that are going to finish in due course of time, and the way the population is increasing, it will finish in no time. So we have to go, the future is the non-conventional source of energy, and the source of energy, conventional, has to be used judiciously and in a sustainable manner, so that the offspring, the people who are coming after us, they also get some energy for their living. Thank you so much. Take care of yourself.